The next chapter is chapter 5, network models. A network is a combination of nodes and arrows. So we have a bunch of nodes, and the nodes are represented by circles, and then arrows are arrows connecting those circles. So we have nodes and arrows, and nodes usually represent a place, or a plant, or a capacity, and often it is referred to as origins and destinations. Some circles will be destinations. So you'll have like a demand location or a customer location. So the circles or nodes representing customers and demand points or destinations. So we have nodes that are origins or destinations. Then the arrows would represent a path from origin to destination. There are lots of problems that can be represented as a network problem, like transportation problem, transshipment problem, and we can also represent other problems like machine replacement and so on as a network problem. We can model some of these problems that we may not think of as network in a network format. And we will have problems like shortest distance problems and maximum flow problems. And we will be discussing many such problems in this chapter. So let's start with the most basic and simple problem that can be represented as a network problem, and that is called a transportation problem. A transportation problem is one where we have origins, which are capacity locations or plants in this case, and then we have destinations, or here in this example we have regions, region 1, 2, 3 and 4. So this is an automobile manufacturing company that makes automobiles in these plants. They'll have to ship the automobiles from these plants to the 4 regions, and there is a limited capacity for each of these plants, how many units it can produce in a given time period, and for the same time period what is the demand in these regions. So we have demand at the bottom, and then we have capacity here. Now the numbers that you see inside the table are the transportation costs per unit. So if you transport one car from plant 1 to region 1, it's going to cost you $131. Okay, one car from plant 1 to region 2 will be $218, and so on. So our objective is to set up a model and develop a shipping plan. How many units should be shipped from each of these 3 plants to each of these 4 regions, such that we stay within the capacities in terms of how many units we ship from the plants, and we satisfy the demand for these 4 regions. Okay. Now let's look at a network representation of this same problem. So here is a network, and here are the circles. There are 7 nodes. These 3 nodes are origin nodes, and we have capacities, and these 4 nodes are the destination nodes, the regions, and the demands are given here. And the arrows indicate the transportation path available going from each plant to each of these regions. Suppose if a plant cannot supply to any particular region, then you will not have an arrow connecting that plant to that region. The numbers that you see are the transportation cost per unit. Now our task is to set this up in Excel and run solver to find the optimum shipping plan. Here the optimum shipping plan would be one that minimizes the total transportation cost.